Hello Internet, welcome to my video on color vision deficiency. The reason that I called it CVD as opposed to color blindness is because, contrary to popular belief, you are not blind to colors, more that you just have trouble distinguishing some colors from others, mostly on varying levels. So you get color blindness not through transmission, but by inheritance. So as you will see in this flowchart, I am going to draw the father as a person with color blindness. Before I get into the specifics, it's worth noting that colorblindness is a recessive gene, meaning that it sits in the second allele, the less dominant sister to the first allele. However, in this case, it can depend on who's carrying. Color deficiency sits in the X chromosome, something that the father only has one of. So when he passes this on, it will go to his daughter. But the only way for the daughter to experience color vision deficiency is if her mother herself is carrying or experiencing the symptoms herself. Otherwise, the mother's chromosome will override the father's X chromosome, thus meaning that the daughter is simply a carrier. On the other hand, if the mother is simply carrying, it will go directly to her son regardless of what the father is experiencing. So the son will be totally colorblind no matter what happens, whereas the daughter will be left untouched. As you can see up in the corner, the father has been left completely clean. However, if the father is experiencing symptoms, then the daughter will, like as you explained before, the daughter will be born a carrier or experience the symptoms herself. So here's a little flowchart to give you an idea of all the different types of color blindness. First, we have animalis trichromatism. This one's the weakest, but also the most popular because red-green color blindness sits under this one. Secondly, we have dichromatism. This one's a little bit more severe, and again, red-green color blindness sits under this one, but so does blue-yellow color blindness. This one sits under the trichomalae and tritanopia cases. Third, we have monochromatism. This is the rare one where you can only see in black and white. So just under this flowchart, I'm going to quickly do a diagram of the wavelengths. On the y-axis, we have how well each cone receives the color, and on the x-axis, we have how long the wavelengths are. Beside this, I'm going to do a diagram of a retina. It'll show you sort of where in relation the rod cells sit with the cone cells. Those black stripes there, those are the rod cells, and then you can see we have the blue, green, and red cone cells. Red obviously has the longest wavelength, green is in the middle, and blue has the shortest. These rod cells that I talked about will come into play later when we talk about monochromacy. So going back to animalis trichromatism, you'll notice that the prefix tri is mentioned. So even though all three of our cone cells are working, some of them may be off, meaning that we will be more liable to mix colors up. You can see that protonomalae and deuteranomalae are responsible for red-green, while tritomalae is responsible for blue-yellow. These cases will get more severe in dichromatism. So you can see here that the red cone is shifted, meaning that we will now not pick up red as well and may mistake it with other colors. This in animalis trichromatism isn't too serious, but it's still bad enough that you will have some restrictions laid against you. So seeing here, I'm just doing a little comparison of what it's like between normal vision and between having red-green color blindness in the form of animalis trichromatism. So on the left here, you'll see that a kid got his kite stuck in the tree. I don't know why I drew that. Some people just like to watch the world burn. On this side, however, you'll notice that the green's a little bit different. The tree's also worsely drawn. So overall, the colors aren't much different. They're just faded. So it isn't a huge difference, but once you get into the real world with more colors, it adds up a lot. So let's jump ahead into dichromatism here. For those of you who picked up on the di prefix, congratulations. It means that only two of your rod cells are working while the other one is not working whatsoever. Again, we have red, green, and blue, yellow. So in this diagram here, the green cell doesn't work, so blue and red have to go in and compensate for it. This leads to severe color mistaken colors, and where you cannot see many colors and they're just gray or mixtures of other colors. So in normal, everything's normal. But when on the right, when we get into blue-yellow, blue is now more of a green shade, while yellow is more of a violet-blue shade. But more severe than that is monochromatism. This is the rare case where you can only see in black and white if you have rod monochromatism. If you have blue cone monochromatism, you can only see in black and white, but your central vision is severely altered while you can only really see out of your peripheral vision. So in this diagram here, you either only have one cone or you don't have any cones at all. This can lead to total color blindness, and everything is in black and white. So I'm going to get into another diagram here just to kind of show you the difference between rod and blue cone monochromatism. So this is rod monochromatism, where everything's in black and white. Again, the kid has his kite stuck in a tree. I don't know how he got it up there. And basically everything is just in black and white. But once you get into blue cone monochromatism, you'll see that I altered your central vision while your peripheral is mediocre at best. So that last part was a little bit depressing, so I'd like to get into some fun facts here to kind of lighten the mood, leave you on a good note. So fun fact number 1, the world's most popular color is blue, which is my favorite color too. Secondly, Mark Zuckerberg is red-green color deficient, hence the reason that Facebook is blue, the color that he can see best. May 20th is Blue Cone Monochromacy Awareness Day. Keep that in mind, mark that on your calendar, one of the more obscure holidays. In Las Vegas, you can legally be married at any Taco Bell that you find. There's a genetic mutation in some women that allow for them to have a fourth cone cell, meaning that they can see 100 million different colors as opposed to the 1 million that regular people can see. And finally, women see color better than men. This is due to an evolutionary trait where minor differences in berry shade and texture meant the difference between poisonous berries and edible berries. So while the men were out hunting, the women were picking the berries, and only the ones with the best color differentiation survived. So those were just some fun facts. I thought you'd like them a lot. I had fun picking those ones out. So I'd just like to say thank you very much for watching the video, and I hope you enjoyed it.